Hello students, today we're going to be talking about properties of exponents. Please don't forget to take notes as you go and complete the survey that follows this video. So there are three properties that we're going to be discussing today, so this should be nice and quick. And I want to make sure you understand why we need to know this. In the near future, we're going to be multiplying polynomials together, and the process of multiplying uses a lot of these properties that we're going to be doing. You can also use these to solve area problems in geometries, because a lot of it involves multiplying base times height. We're doing 1/2 base times height for a triangle, so knowing these properties is going to be extremely helpful for those. So let's take a look at an example. So in this one here, I have x to the 5th times x to the 7th. Now, we know that exponents represent multiplying the same thing multiple times. So let's expand that. X to the 5th means x times x times x times x times x. So we have 5 x's there. If I were to do x to the 7th, I would do the same thing, but I have 7 x's. Well, now I can take this and simplify this even further because I have a total of 12 x's. So as we know, the exponent represents how many times I'm multiplying it by itself. I can rewrite that now using an exponent. In other words, I can rewrite this as x to the 12th. So now what I want you to do here is look at the relationship between this x to the 5th and x to the 7th and this other process here, or other number here, 12. And what I want you to notice is that if I were to take these two numbers here and add them together, I'm going to get that the 12 over there, that exponent. So that's our very first property. It's called the product of powers. The key thing here is that I have to have the exact same base. So it has to be a to the b and a to the c. And of course, a is going to change depending upon what we're using. It could be x's, y's, and z's. It could actually be numbers too. But the big idea here is that if I were to take b and I add it to c, and that's going to be my new exponent as long as I am multiplying. That's the big key thing here, is that this involves multiplying. So now let's look at a different example here. I have x to the 5th in parentheses, and on the outside I have this to the 3rd power. So let's break this down a little bit further. So I have this 3 on the outside. What that means is I'm taking x to the 5th and I'm multiplying it by itself 3 times. So I'm rewriting it as x to the 5th times x to the 5th times x to the 5th. Well, we just learned that if I have these guys here being multiplied, we can take those exponents and add them together. So really, I can do 5 plus 5 plus 5. Well, now what I want you to do is looking at the relationship between these two numbers here, the 5 and the 3, and the number outside here. And I want you to say, all right, well, what pattern do you see is going on? Well, what I'm noticing here is from 5 to get from 5 and 3 to 15, I'm actually taking those numbers and multiplying them. So that's our next property. It's called power of a power because you see we have our exponent, also known as powers, raised to another power. So as you can see here, if I have a single entity inside, see that a there, to an exponent, I can then take that and multiply by the exponent on the outside. Now keep in mind that that b out here could also be a 1. So just keep that in mind when you're solving some of these problems, is that it doesn't have to have a number here for us to kind of distribute. That's what I want you to think about, is you're kind of distributing that c to the exponents inside there and making sure you're multiplying every single exponent by there. And it could be the number 1. Our final one here is looking like this, where now we have 2 things inside the parentheses. In the previous one, we only had 1 thing. So now what I want you to notice is I'm going to rewrite this out and see what happens. So I have this a times b to the 5th power. That means I'm doing a times b times a times b times a times b. I'm doing that 5 times. Well, what you're going to notice here is I have 1, 2, 3, 4, 5 a's and 1, 2, 3, 4, 5 b's, and we just talked about that. If we're multiplying the same bases, we're going to put those together. So what I end up getting is a to the 5th because I have 5 of them, and b to the 5th because I also have 5 of them. And what I'm seeing here for the relationship going from this first one to the next one, what's actually happening is it looks like this 5 is being distributed to both of those things here. Now we can also have it where it looks something like this, where if I have like a to the 3rd power, sorry about that, times b to the 2nd power, keep in mind that doesn't have to be just a and b. But if I have something on the outside, like say like the number 4, when I go through and I give this exponent to all the stuff that's inside there, remember from the previous one, is I'm going to be multiplying it by that 3 and that by 2 and by that 2. So what I end up getting here is a to the 12th times b to the 8th. Anyways, our final property is called power of a product. Please make sure you get that written down. The power of the product is if I have 2 things being multiplied by or raised to the same exponent and there's a product inside, I'm going to essentially take that C and distribute it to everything that's inside, as long as it is a product. If there is a plus sign there, it is a totally different process, so please make sure you do not complete that. Please make sure you complete the survey that follows this video and that you have taken full and complete notes. I'll see you tomorrow.